So today we're going to continue our discussion about standard deviation, and we're going to kind of make sense of it today. We're not going to actually calculate it. We'll do more practice with that tomorrow. All right, so this is a normal bell curve. A normal bell curve is symmetrical. First of all, it's bell-shaped. It's symmetrical. Therefore, 50% of my data is from here and up, and 50% of my data is from here and down. Symmetrical mean. My mean is equal to my median, and they are both at the center. So that's where we always start, is with our mean. They are not the same thing, but if it's normally distributed, they'll be in the same place. That's a really good question. Okay? All right. I just want to go straight to, well, let's look at this. So I gave you this piece of paper, okay, and what that piece of paper tells you is that within one standard deviation, so if this is the mean and the median, within one standard deviation, the spread, right, a spread within one standard deviation, depending on what the spread is, you're going to have 68% of your population. The majority of your population is going to be right there in the middle. 2 standard deviations, you gain, goes up to 95%. So if you take that 95 and you subtract out the 34 and the 34, or the 68, you would get what? 27? Yeah. And you split the 27 in half, and that gives you 13.5 and 13.5. Okay so far? Anybody need me to restate that? You're just, just subtracting. The whole thing is 100%. But when we have a normal distribution, Sandra, put it away. When you have a normal distribution, within one standard deviation I've got 68, within 2 I've got 95, and within 3 I have 99.7. So where do I get these numbers here? Well, I take my 95 and I subtract 99.7 minus 95 is going to give me 0.7, right? And then 9 minus 5 is 4, 4.7. Am I wrong? I'm just trying to find how much is right here and right here. If I divide it by 2, do you see how I did that? If I know from here to here, it's 99.7, and from here to here, it's 95, then I would take the 99.7 and subtract the 95, and that gives me 4.7, and if I cut that in half, I get 2.35. So that's where this is 2.35, and this is 2.35. So what's left in the little tiny tails down here? 0.3, because I've got 99.7. 100 minus 99.7 is 0.3. If I cut 0.3 in half, I get 0.15 and 0.15. This is where I think I lost them last period. I know you have seen it before. You saw it in Algebra 1. Yes. Okay. Any questions on this part of it? I think we just have to use it. All right? You don't have to memorize it. You've got your little cheat sheet right there. Okay? So let's talk standard deviation with this now, like for real. So let's pretend, I'm going to skip over some of these. Let's pretend that we're back to that IQ scores again, because I think you guys understood the IQ scores, right? Okay, so the first step is to draw the curve. So you draw your curve, which I already have a curve right here. I'm going to draw my curve. Your second step, come on, it's been really weird with me today. All right, my second step is to label the mean. When you have problems like this, it'll tell you what the mean is. So this one says, adult IQ scores have a bell-shaped distribution. That means, bell-shaped means normal. That means this rule applies, okay? So a mean of 100 and a standard deviation of 15. There's no need to calculate anything. They told me what X bar is, it's 100, and they told me what my standard deviation is, it's 15. So the next thing I need to do is label the mean. So my mean is 100, always goes in the middle, and my standard deviation is 15. So to get my upper standard deviation, I'm going to go forward, right? So 115, add 15 to 100, then plus 15 more is going to be 130, then plus 15 more is going to be 145, right? So let's start from the very beginning. If we would have not known the standard deviation, we would have had to use the mean, right, with each data point and average it with that crazy formula that you have, and that gave us a standard deviation. Matthew, I need you to wake up, please. That standard deviation is used to show how much of the population is within that. So if I were to calculate the mean and I got 100 and then I found a standard deviation of 15, what that 15 tells me is that a score of 15 more points and 15 less points, which would be an 85, gives me the major population. Their scores are going to be between an 85 and a 115. That's what it's telling us. That's what the standard deviation explains to us. Then, going this way, if I were to subtract and I would get 70, that tells me that 95% of the population are within 2 standard deviations. We already knew that, right? We already know that 95% is within 2 standard deviations, but now since I have what the standard deviation is away from the mean, I know their scores are between 70 and 115. Sorry, 130. So between here and here. That's within 2 standard deviations. Within 3 standard deviations, which is as far as we go, within 3 standard deviations, so this would be, well, we already have it 95. Within 3 standard deviations, I always know, no matter what, as long as it's a normal distribution, you're going to have 99.7% of your population is going to be within 3 standard deviations. Once I know what the standard deviation is, I can apply numbers to that, or their score. So if I subtract 70, I'm going to get 55. So 97.7% are going to score between a 55 and a 145. Anybody above a 145? That's only 0.15% of our population, which is super small. So we don't even go any further. Why would we go 4 standard deviations? You know what I mean? Like, that's such a little tiny tail. All right, so now we're going to answer our question. That's our last one. I draw a curve, I label my mean, I add or subtract to find all of my different values, and then I answer the question. Here's the question. Find the probability that a randomly selected adult has an IQ score between 70 and 130. So between 70 and 130 is 95%. The hardest part is just adding and subtracting, right? Then you just have to make sense of it. You don't have to memorize anything. Okay, let's try another one. Where's my camera? Right here. I'm going to take a picture of this because now that I have it, I'm going to use it for all the problems that have to do with IQ. So cut that. Let's do another one. All right, here's my next one. Same thing. Get rid of these. Paste my picture that I already did. Go a little bit smaller. All right, here's my question. Find the probability that a randomly selected adult has an IQ score between 100 and 115. Okay, 100 and 115. Okay, I'm feeling much better now. Between 100 and 115, is 34%. If I needed to highlight that, I could. Between 100 and 115 is this part of the curve. 34%. Raise your hand if you don't understand where I'm getting that number from. Okay. Next one. Let's see. Find the percentage of adults with an IQ below 85. Let's get rid of this one and this one. And that. And paste it. Below an 85. So here's 85. So everything below it. Let's count. 13.5 plus 2.35 plus 0.15. All those added together, 16%. Thumbs up, thumbs down. How are we doing? Matthew, I need you to wake up. All the way, sit up. I need you to sit up. Okay. Get your whiteboards out. Okay, so the first thing I want you to do is I want you to label your graph. Draw your curve and I don't want to know the answer to the question right now, guys, even though I appreciate it. I just want you to draw your graph and label it. Draw your curve and label it. I'm going to go ahead and pause it. So if you don't have this so far, this is what you should have. Your graph, you really don't need to recreate these numbers, guys. You have your numbers on your chart that you have in front of you. That's always going to be the same. What you really need to have in front of you, right, are the numbers that go down below here. Right here. These numbers. What's my mean? Let's make this a little bit smaller so I can see the question. Sorry. Better? All right. So if my mean is 74, right here, 74. I'm going to label the very middle 74. I have a standard deviation of 8. So each time I go up, I'm going to add 8, right? So 82. Then what? 90. Then 98. All right, now I'm going to go down by 8. So if I go down by 8, I'm going to have 66, then 58, and how much? 50. That's really the only work you need to do, right? You don't have to write all these percentages in here. You're going to refer to them because you have them on your chart. Okay, you don't have to write them every single time. You just need these numbers right here. Okay? So now, here's the question. The question asks me, find the percent of juniors whose score is no more than 90. So who scored no more than 90? Would that be this side of the graph or this side of the graph? The left side. So no more than 90 means I can't go higher than 90 on a score. So there's two different ways you can look at that. The whole graph is how much? 100. So you could add all these numbers up if you want. That's too much work, right? Or 100 minus this this section, which is 2.35, and this section, which is 0.15. So what do I get? 97.5%? Did you guys get that? Thumbs up, thumbs down. How are we doing? $58 to $90? No, I could add, I'd have to add all of these. Because if they had to score no more than 90, that means they could have scored all the way down to here. They could have scored a 0. Does that make sense? Yeah. They could have scored a 0. That's these people down here. Really low scores. Okay, guys ready for another one? So let me take this off. And let me copy this again. And go to the next one. Get rid of that. And bring that to the front. Okay, now here's this one. Put this on your whiteboard. Find the percent of juniors whose score is between 58 and 74. Whose score is between 58 and 74? Oh, I don't have my other... Sorry, you guys have it? Let's go back and get it. I never took a picture of it. $58 and $74. Can you guys tell me? I want to see. How much is between 58 and 74? So, Kayla, you've got the section, right? And back there? What do you guys think? You just finished your graph? Okay. Okay, most of you have it. So between 58 and 74 is between 58 and 74. That's right here. So those percentages are 13.5 and 34. If we add those together, we get 47.5%. Another one? Okay. So this time we're going to get rid of number 2 and number 1. All right, here's your graph again. So tell me the percent of juniors who scored at least a 74. Please don't yell it out. At least a 74. Yep, show me. Okay. So most of you have it. Some of you are calculating it. This is where number sense comes in. No need to calculate it, right? Why? It's in the middle. The middle means half. Half is 50%, right? All right, so I think, let's write it. At least 74 means 74 or above, which is half of the population, 50%. Okay, I think you guys are ready to finish up that worksheet. So do the back side.